Hello everybody and welcome back. We're looking at question 7 now. Question 7 on the Euclid contest from the year 2004. So we got A part, light bulb, in the diagram, AC is equal to BC. Fantastic, they even have it labeled for us over here. AD is equal to 7, DC is equal to 8, ADC is 120 degrees. What is the value of X? Okay. Seems like a very quick cosine law almost. Well, it's a light bulb question, so I'm not going to dwell on that. Let's just redraw the picture. I have a little space here under our question number 6. So we have a right angle, and we've got 7 and 8. 120 degrees here, and we want X, and I think that's it, right? Yeah. So I'm going to let these lengths here, they're the same thing, I'm going to let them be Y. I'm also going to, we've got A was up there, no, A was down there, B, A, D, C, and B is up here at the top. Okay. So, it's pretty clear that x squared is going to be 2y squared. Now, going a little faster, it's a question 7. You guys should know some of this stuff if you're attempting these ones. Just simple Pythagoras, don't worry. So 2y squared there. And then, by cosine law, see, I never used cosine law in real life, so now I have to try and remember what it is. Sine law is the pretty quick one to remember, but y squared, because the way I remember cosine law is it's basically Pythagoras. So the longer one, or the one that we're talking about, is the sum of the squares of the other two, but then it's minus something involving the cosine of the angle. And then when this is 90, this becomes 0, so this part goes away, and it really is just something squared. The hypotenuse is the square of the other twos, the sum of the squares of the other two. And then the thing we put in here is times those two lengths again. So times 7 and 8. Okay. Cosine of 120. Do I remember that off the top of my head? I'm going to draw a quick unit circle. I try and avoid my calculator whenever I can. Cosine is the x's, so 120 is going to be somewhere over here. With 60 here, so that would put a 30 up here. So the height is going to be bigger, so this is going to have to be -1/2. So we'll get 49 plus 64 minus the 2.5 will go away. 7 and 8. So 2's will go away. The minuses will become a plus. So it'll be 49 plus 64 plus 7 times 8, which is 56. And then we got to add that up. The 4 and the 6 is a 10, so this here is 120 plus another 4, 9. That'll be 169. Oh, y squared is 169. Nifty. Okay, now I could solve for y being 13, and that would be perfectly acceptable. But we don't actually need it. If you look down here, we just need 2y squared. So x squared is 2y squared. So that's going to be 2 times 169. 8, carry the 1, it'll be 338. So x is the square root of 338. But if I just square root this 2 and this 169, I get 13 root 2. And that would be what I put in. X is 13 root 2 is probably the simplest way to write this. Not a bad question, actually. Kind of quick. Cosine law, I think, was really our only option here. So it's important to know our trigonometry, especially for the Euclid. It does pop up, I think, from time to time on the Fermat. Not so much on the Cayley, definitely not on the Pascal, though. Just based off of North American high school curriculum. Anyway, B part, the written part, the thing we should probably be explaining with sentences and fun diagrams. Speaking of which, in the diagram, a drawer, P-R-S-T, that happened to Q. Oh, there's Q. So we're going to use Q later. So a drawer that is 11 centimeters high is in a long slot, A, B, C, D, which is 15 centimeters high. Okay. The drawer is pulled out so that the midpoint of its base rests at C, and they've marked that it is a midpoint. The drawer is tilted so that the top back edge of the drawer, P, touches the top of the slot, AB. So P lies on AB in this picture. If the angle between the drawer and the slot is 10 degrees, okay, looks like BPQ is what we're talking about. Determine the length of the drawer, so determine PR or TS, to the nearest tenth of a centimeter. Okay. Just based off of what 7A was, I think I mentioned this before, I've definitely mentioned it on past contests, you usually will notice that, not always by the way, but you'll usually notice that on the Euclid, parts of questions tend to be related. So 7A, we used cosine law. I'm betting we'll have to probably use cosine law here, or maybe the other one, sine law. Just a guess, don't quite know. That 10 degrees in there, he's kind of awkward. So I'm definitely thinking we'll probably be needing our calculator to do something. Cosine law, sine law, whatever. But that's just based off what we had to do in 7A. I think cosine law or sine law. Just things in my mind, and I want to share them with you because maybe you'll start thinking that way as well. This doesn't always happen on contests, though, but usually. It's more prone to happen on the FGHs because I think those questions are designed, whereas sometimes Euclid questions are just, we have two halves of a question, let's stick them together. Okay, well, I don't see anything immediate to do other than start diagram chasing, and that usually means we need to draw a picture. Okay. So we have our drawer. This actually isn't turning out to be such a bad picture. The drawer got a little wider, but not appreciably. So we got Q here, B here, P lies on AB, C, D, that's a midpoint right there. Now I think a mistake might be to think that Q here splits PQ and there's P, Q, R, S, and T here. A mistake might be to think that we get midpoint here and that we've got something going on. Or that QC is 11 or something like that. That would also be a big mistake. What can we do? Alright. So, we've got a 10 degrees in here. Since this is 90, that means this is going to have to be 80 degrees. And so then this fellow over here is going to be 100 degrees because he has to make a whole line with BQC. We want to get a height of, we want to get the fact that we've got a height of 11 in here somewhere. So I'm going to drop a perpendicular down here, and this is 11 centimeters. I don't know if this is useful, but we've certainly got that going on a bit. Okay, this angle in here will be 80 degrees because TS is parallel to PR, so they hit BC at the same angle. So that gives us a 10 degrees there and an 11, and I think that's enough to get QC. Minus the 15, we get BQ. And then from there, we can get, I don't know, PB. And sort of spinning my wheels a bit there, but might get something. It's certainly worth exploring. Maybe something better will pop up in a moment. But what should I say? We're told angle BPQ is equal to 10. So angle BQP is equal to 80 degrees. PRST is a rectangle. So PR is parallel to ST. So they both hit BC at same angle. Oh, if this is an 80, then this here's got to be a 10. And so if I could just work out where T is, maybe that's what I need to do. Because T being there, and then 11 here, and if we complete that, we'll get... Oh, yeah, that's going to be nice. So actually, I don't need what I'm writing right now, because I could... I'm gonna scrap this page. But I think I got a slicker way to do it. Okay, redraw the picture. Oh, now I really hope my slicker way of doing this works out. And that I didn't just erase a whole bunch of work for nothing. Okay. P, I got B, I got A, D here, P, Q, R, S, T. Okay. So I'm going to add in points, A, B, C, D. We're going to go with E up here and F down here. So I'm going to say construct height EF of rectangle ABCD. So T lies on EF, as shown. Alright. So we got right angles here, and from those we can see, so angle BPQ is equal to 10 degrees. So angle TPE is equal to 80 degrees, because it's got to, with the 90, make the full circle. Or not the full circle, the full line. We have right angles here and here. So angle PTE has got to be equal to 10 degrees. And once again, we got to make a full circle, so angle CTF has got to be equal to 80 degrees. And angle TCF has got to be equal to 10 degrees, as we already stated before I erased this whole picture. Okay. Now, PT is equal to 11. From there, we can get the height of ET. We can get length ET using the sine law. And then from there, we can get TF, because we got to have a total of EF being 15. And from there, using either similar triangles or sine law again, we can get CT, double it to get ST, and that was what we wanted. We wanted the length of the drawer. Length of the drawer to the nearest centimeter. There we go. Okay. So, by sine law, PT over sine 90 degrees is the same as ET over sine, what's it opposite? It's opposite 80 degrees. Okay. So ET is sine 80 degrees. Sine of 90 is just 1. So it's going to be 11 times sine of 80 degrees. Oh, we could also just use SOHCAHTOA. So we don't actually need sine law. We won't need sine law anywhere. Do I want to rewrite it? Yeah, I think it's a little more elegant to use SOHCAHTOA with all these right angle triangles sitting here. So, for those of you not in the know, for those of you who don't remember your trig, if we have an angle here, and it's in a right angle triangle, we have the opposite side length, we have the adjacent side length, we have the hypotenuse. Sine of theta is opposite over adjacent, or opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So this is S sine is opposite over hypotenuse. Ka toa. SOHCAHTOA. What do you do when your foot's on fire? You SOHCAHTOA. Okay, so then by SOHCAHTOA, we can rearrange this and say opposite. So the opposite of this 80, which is ET, is going to be PT times sine 80 degrees. So that's 11 sine 80 degrees. Okay. TF is EF minus ET, so it's 15 minus 11 sine 80 degrees. Alright, so now we've got TF. We have opposite of the 10 degrees, or conversely, we have adjacent of another 80 degrees, doesn't really matter. And so we can get CT. So CT, the hypotenuse, so CT is going to be, you do the opposite over the sine. So this is TF over sine 10 degrees. We're going to flip this over to the other side. So CT is 15 minus 11 sine 80 over sine 10. C is the midpoint. The length of the drawer is ST, which is 2CT, which is 2 times this expression right here. So as soon as I plug that into my calculator, we're done. We'll have to the nearest centimeter. Now, before I do that, I would like to make a note, just a little bit, sort of a word of suggestion almost, and that would be, so take a look at these calculations. So go back for a second. So we could have at the very start here, as soon as we got this ET, we could have plugged it into our calculator and rounded. You know, we could have. And then we could have plugged that with the 15 minus that, and you might have been tempted to round, divided by the sine over 10 and round. And so just as a word of caution, when you're doing a question like this, and eventually you know at the end you're going to have to use your calculator, there's the temptation to use your calculator sort of all along. And that can introduce rounding errors, which can become a very serious problem, and you can actually round your way away from the actual answer that you want. So what I like to do, and what I suggest you do, is keep everything exact like we did here. You know, we didn't do 11 sine 80 is, what is 11 times sine 80? 11 times sine of 80 degrees. That'd be 10.832. We could have rounded that to 10.8, and that could have messed up our calculations later on. Because then we would have done 15 minus 10.8. That would have been 4.2. Divided that by sine 10, and we might have rounded away from the actual answer we want. So keep everything exact until the end, and then just do one big put into your calculator. Okay? Now, sometimes that's inadvisable. Like if it's a really big calculation at the end, you can lose track of it on your calculator. So if you're going to round as you go, don't round to what they're looking for. They're looking for the nearest tenth of a centimeter. Don't round to 1/10 if you're going to plug these things in. Round to 2 decimal places, 3, 4, that sort of thing. Okay, so let's get back to it. Get our calculator, and we're going to finish this calculation off. Okay, so what have we got here? All right, so this is going to be equal to, and now just plug in. So 15 minus 11 times sine of 80 is 4.167 something something. I'm not going to round that. I'm just going to straight divide by sine of 10. And I get 23.99 something. Now I'm going to multiply that by 2. So I get 47.994914446. This is as much as my calculator is willing to handle. And they said to the nearest tenth, right? Nearest tenth of a centimeter. Well, all these 9s are going to round everything up to 48.0. And yes, it is 48 that we're rounding to, but leave the 0.0. It shows that you are going to the tenths. Okay? But there's my answer, 48.0 centimeters. All right. That's an interesting question. We didn't have to quite use cosine law or sine law. I mean, I thought we were going to have to use sine law, but ultimately we did use trig. So this is sort of the trig question. We had to use trig in part A. We had to use trig in part B. Okay? So coming up next is 8. 8, 9, and 10, I believe, are all written. Let me just quickly scroll down on my screen. Yeah, they are all written. But 8, 9, and 10 typically are where the questions can get a lot harder, especially 9 and 10, but 8 is usually lumped in there. When we go down to mark the Euclid, there's a room just for the people doing 8, 9, and 10, because those are the ones that people tend to have the most difficulty with, so we group them together and mark the hard ones as one group, and then it's 1 to 4, and then 5, 6, 7 for the others. But you don't need to know that. All you need to know is in the next video, we're going to take a look at question number 8. If you haven't already, please take a look at it, and that way you can be better prepared as you watch me go through it in the next video. Okay, so long for now.